Hi, how's it going?
Very good.
My name's Joe Locasio. I'm here from the Bay Area. So I actually flew here. I'm here an overnight flight, about 12 and a half hours on a plane. My role's a little different than Bo's. I have this title. I'm a software analytics architect, which is a sort of marketing spin on SEO engineer, essentially. I'm here to actually do workshops with customers, so I've just spent the past 2 days doing training, customer training with the Autodesk team in this room. It's half as big as it was now. And I basically do that all the time. So I don't do talks every month. I do training in person, demos, actually work with customers on implementing things in the pre-sales environment. Today I'm going to talk about some of our explorations in serverless instrumentation. So Buzz talked about actually debugging in the development environment. I'm going to talk to you about actually like managing runtime performance and things like that of serverless apps. How many of you guys know what New Relic is, first of all? Michelle, Steven, Autodesk guys that are raise your hands. Some of you guys have never used New Relic? Cool, perfect. So the slides I put in here in the beginning are not with this. So at its heart, New Relic is an APM company, APM being application performance monitoring. We have, like everyone, we have the platform. Our platform includes an analytics component, insights, that sits on top of all the other products. And New Relic promises to be able to monitor and analyze, alert on, dashboard, anything pretty much. So that's applications. We have language agents that support 8 different application languages with automatic instrumentation for the code you write. You write a Java application, you monitor all the methods and functions of the app. We do the same for infrastructure. So cloud infrastructure, actually a lot of customers still run premise infrastructure, OpenStack. We instrument that as well. We instrument the cloud services on the infrastructure as well, RDS, S3 buckets, straight cloud buckets from all the Amazon services. We also have customer experience monitoring solutions, so browser, mobile, those are things that can monitor applications in the end user's environment. You have a mobile app, you load it with New Relic Mobile, you can see how fast your session is, things like that. Synthetic monitoring, if you've ever run something like Kingdom, same thing pretty much. We can run Selenium scripts and test applications over a continuous period with like in a clean room environment. Consistent testing to conceive actually good performance trends over time, every asset, every page, and things like that. In the APM world, we promise to trace applications when they're not performing well, right? So you can debug them. And that's in production. And we do the automatic. Well, along came this thing called Lambda. We typically install our agents onto servers, right? Well, how does that work in a serverless environment? The answer is doesn't at all. So it's actually kind of an interesting time in New Relic. Customers are migrating new greenfield development to Lambda services. And that's not restricted just to Amazon, but primarily Amazon. So this kind of breaks our promise to our customers, right? We're not able to monitor every application we plan out, but we're working on it. So with Lambda services, you get to not worry about your servers anymore, right? It's actually one of the most discussed things, I think, in technology conferences these days. Well, I get to write my code, ship it to production, and it's just stop caring about the servers that it runs on. And that's been extended to things like, Fargate, running containers on a platform and just run them wherever you like. While you're not worrying about servers when you're serverless, probably still care about performance a little bit, right? Why would you worry about performance in a serverless environment? Well, user experience, all the same reasons you would in a server environment, right? Also, cost reasons. If your application's not performing well in Amazon and you're exceeding, I don't know, 3 to 5 minute runtime or something like that, second runtime, that's going to cost you a lot more versus having highly efficient services. So we're going to explore a little bit of data collection that we did with Relic products around serverless infrastructure. And in our example case, the architecture is an Amazon API gateway, very simple, and a Python service that's written in Lambda. The Python part is important, but I'll tell you why later. So we're going to take a tour of the sample data that we collected with our synthetic products, and we actually found some interesting patterns about the way that the service was performing, depending on how frequently we hit it. It's not a dig at Amazon, but this is just an interesting thing we observed with like cold start times in Amazon AWS Lambda services. So this is our synthetic monitor, and it's testing our Lambda service at 1-minute intervals. And it essentially gives us a scatter plot of response time that's fairly inconsistent, right? The Lambda here is running in one AWS location, so on one region. So we wouldn't expect, this is running from one location on our end too, we wouldn't really expect a high distribution of different response times like this. It doesn't really make sense to us. Using synthetics and analytics engine, we're able to break this out, and we actually ran more tests. So we ran tests from synthetics, same location, more frequently. That's the green line here. So running once a minute or twice a minute from 2 locations. And then the other ones are running more frequently from, or less frequently, against other Lambdas. And those are the same code. And they have very, very different response time patterns. So if you have actually deployed some serverless applications, you'll notice there's like a cost to not running them so frequently, cold startup time. And we don't want to just invoke the Lambdas to keep them warm and performing. That doesn't really make a lot of sense. But we need data so we can tune them, right? That's the promise of instrumentation. Get data to tune the service, make it perform better. So here's the distribution of those requests. We could actually see test 3 super fast, almost 600 milliseconds duration in the 95th percentile, and we see like an elevation of connect time in those ones that are running less frequently, and overall wait time is also much higher. So these are different attributes that we collect that instrument the actual TCP connection, HTTP connection, things like that. If we flip that guy on a histogram, we get 2 buckets. Over a day period, they bucket out into either 200 millisecond response times or 500 millisecond response times. But we can't see much more than that. We can tune a bunch of settings, and actually, if you're running synthetic testing Lambdas, you're probably getting charged for it. It's not really a good way to instrument your Lambdas. I'll admit that. It's just a scenario to show what we can do with synthetics and some observations. So while we're able to ping these with synthetics, we also actually are able to instrument them a little bit today with GA capabilities of what's called Relic infrastructure. So to avoid that excessive Lambda monitoring with synthetics, we deploy the infrastructure agent onto your cloud environment, and then it actually has the capability to scrape up all the CloudWatch metrics. Infrastructure has over 30 different cloud integrations for Amazon, from things like S3 to ECS. Whatever you're running, we probably instrument it. We store that data in infrastructure for 13 months. There's a base set of metrics there. Here's my synthetic monitor. I'm just going to go ahead and show you what some of the default metrics are that we can collect from a Lambda from CloudWatch. If you're familiar with CloudWatch, you've seen some of these metrics. We scrape all of them out and put them alongside your application data, right? So, average duration of all the Lambdas you're running, number of invocations, whether or not they got throttled, and then exceptions, errors, and something that's unique about infrastructure is events roll. So anything that changes in the environment, if you deploy a new Lambda, you pick that up, store it as an event in infrastructure. This also feeds an inventory feature where you can inventory all of the functions inside of your environment. And that's all done with a single integration. You create a role, integrate infrastructure. So that's the surface level information that you could already get from CloudWatch. But we really want to take this 1 or 2 steps further, really. That's where some custom instrumentation comes into play. So using our same architecture, we actually wrote a wrapper. I planned to have a demo of this. Unfortunately, died a horrible demo death earlier today. I do have a running example of it. I need Bo's help actually at the end of this, because I'm using SAM that he was presenting about to build the CloudFormation stack and deploy it, and my log fire hose won't create properly. It's killing the entire thing. So that's just me being an interview, that's pretty much. But we can wrap those functions, and in fact, we actually have an alpha of our agents that we're developing for serverless applications. So the promise of being able to automatically instrument your applications and show performance, show exceptions, logging information, things like that, we could actually get very similar APM data using the new, we're going to call them for now, enhanced instrumentation capabilities. So the way this works is actually a wrapper that you put inside the Lambda, and then you call the wrapper, and the wrapper calls your Lambda. So it's a bit of a middleware. It's a very, very lightweight middleware though, and it instruments every execution of every Lambda. It pushes that out into insights, and we get executions, execution time. We can even get trace IDs and things like that. So duration, memory, exceptions. Luckily this guy's running happily right now. But being able to actually instrument the application as we normally would is a huge win for us. It's going to save us a lot of time troubleshooting our Lambdas and managing the actual performance of them. So this is much better than this. So that's V1. What else do we want to have? Question?
What's the performance impact on the runtime of the Lambda?
It's microseconds. It's seriously, it's just starting a timer when it works it. You can also trace things like exiting the Lambda service. So calling your Dynamo DVD, you can instrument those calls much like we did with the before the service. Still alpha. You won't see anything from us for a while on this, but I think it's important to get out of the community and actually help people pass it.
Did you say microseconds?
Huh?
But only sending the information would take a bit more, no?
It's sending it out of Kinesis Firebase, and then we're creating a log subscription, and then we have another function grab the logs.
So just the network latency would be more than microseconds.
All within Amazon, within
Yes.
CloudWatch trips.
Tens of microseconds.
Tens of microseconds. I mean, I think
It's gonna be a few milliseconds.
all right, we'll call it milliseconds. I'll acquiesce. So what else will we want to see inside of a measurement platform for serverless applications? We want to see errors, exceptions, traces, logs. You probably have some different questions you want to ask of your serverless applications, right? You want to ask where invocation time is being spent when you have cold starts. How fast are those AWS services that you're interfacing with in your Lambda? Initialization time. If it's running initialization code? How frequently is that happening? And then lastly, as we discover synthetics, like can we tune it, right? Can we manage the memory footprint? Does that reduce the response time from cold starts? You can even do things like maybe play around with the runtime. You have a Python Lambda, switch it to Python 3.6, see if that helps a lot. So we hope to continue to be the instrumentation platform for your infrastructure code. And so my purpose here is to actually get some feedback from you guys. I know earlier some of you raised your hands as to whether you were running Lambdas in production. If you're running a serverless application, I actually want to talk to you at the end of the talk. It'd be really nice to understand what some of the challenges you're having are, and I can bring those back to my development team as we start to develop this serverless instrumentation. So it's an interesting problem to solve, and I think we're not going to just solve it by ourselves. We need your guys to solve it. So yeah, come talk to me after this. Talk to me about whatever you've done to custom instrument your Lambdas, and thanks for listening.